Data governance is not AI governance, and we're here to talk about the AI governance part of it. I just want to put a disclaimer at this moment, because what we're going to be talking about, me and Sean, is something that is a take of our experience with the past couple of months, updating our AI governance playbook, as well as drafting the Gen AI governance playbook. So this is going to be like our personal kind of experience, our personal kind of take on that. It's by no means like the whole policy that we developed, and we're not taking any responsibilities of kind of like anything that we're saying over here. So anybody who's taking any notes in here, you should be responsible by kind of like leveraging that understanding and kind of doing your own research in order to implement that. These are going to be somehow some pointers to where to start and how to kind of like move forward with that. So we're talking about the portfolio-based risk management in the AI models. What do we mean by that? Basically, and why do we need that basically? So basically, Gen AIs are actually providing a little bit more complex way of like managing risk because it has a lot of different components to it. So that's why coming up with the potential risk of models that are out there, that we're putting out there, is somehow the best way to kind of like be able to manage it. So we have to kind of detect the risk portfolio of each application and then be able to kind of like mitigate those type of risks. Why are we saying portfolio management, portfolio-based approach is actually a good idea? Because a lot of Gen AI applications are sharing a lot of components, such as the underlying LLM model, the way that they are handling things, and the purpose. Most of the time, the purpose are pretty much the same as well. So looking into a holistic way of like how we're managing the whole portfolio of Gen AI applications is actually beneficial for the organizations. And the last thing is that the integrated risk management can give us the opportunity to have a peace of mind while we're developing the models, that like we're developing the models in terms of like adhering to all the rules and regulations that are kind of tightening our hands in the financial institute on building AI application and models. And it kind of allows us to move to production a little bit faster and better, and with peace of mind. Now, in this presentation, we're going to be focusing on three main components that we have to consider while we're developing the models, and in order to kind of like distinguish the risk that we are exposed into it. The first one is the concentration on the risk at the model risk profile level. So we have to come up with the potential risk that any application is actually putting us in place, and kind of come up with an idea of what is the risk tolerance of the organization based on those risk portfolios. So first, appetite of the organization, then the components that are kind of like exposing us to those type of risk, and then coming up with an idea of where we can find the balance, basically. The second thing that we're going to be looking into is looking into the model components. As I said, a lot of models are sharing similar components, and looking into a holistic way gives us the opportunity to move faster, to be more flexible, to handle incidents pretty faster. The last thing that we're going to be talking about is model jurisdiction. Every single jurisdiction, especially in US, have their own rules and regulations, especially in the financial sector. So it is very valuable to look into Gen AI applications that are built for that jurisdiction and kind of be able to be confident about adhering to all those rules and regulations for that specific jurisdiction. So these are the things that we're going to be focusing on right now, and we're going to give you some examples and some applications and some best practices based on our experiences within the past couple of months dealing with all of these stuff. So I'm going to pass it to Sean to talk about the risk profiling. As I said, risk appetites and the risk portfolio is one of the main components that we have to be specifying for any Gen AI use case. Sean, please.
So I and Paris have been working very closely on developing our first Gen AI model risk management policy at Manulife. And one of the key concepts, or one of the key lessons that we learned from that exercise, is this concept of model risk profiling. And the reason for this is because AI risk has become so multifaceted, right? It's no longer a pure financial risk. It can carry reputational and operational risk as well. So being able to, I guess, classify these AI risks into different buckets that we can, act upon is really key to AI model risk management. So before we begin, can we go back to the previous slide?
Do you want to go back?
Yeah, the previous slide.
Yeah, sorry.
Yeah. So before we begin, I just want to give you some background on the history of model risk management. I know that model risk management is not exactly the most exciting topic, and the history of model risk management doesn't make it any more exciting. But this is to give you some background. So model risk management really became an important practice since the 2008 financial crisis. It was because of this model called the Gaussian cupola that to some extent contributed to the financial crisis of 2008. It was coined the formula that broke Wall Street. I guess to most of the people here, so you may be familiar with the model. Essentially, it is a model to describe the dependency structure between different credit instruments. And the key limitation of that model is that it underestimated tail risk in stress events. And that resulted in, that of course contributed to a lot of the underestimation of the tail risk involved and mispricing of credit instruments, which contributed to a financial crisis. And as a result of that, we got SR 11-7, which is the first, policy that formalized model risk management as a practice. Since then, I guess almost 20 years has passed, and model risk management has really changed. So model risk is no longer a pure financial concept. It has also evolved to include operational and reputational risk. So next slide. Yeah. So what we have implemented at Manulife is we recognize that there are different AI risks. So what we do is, in the model submission process, we ask the model owner to identify, say, the top 2 or 3 risks that use case exposes us to. So this is a list of potential AI risks. The first row here include all the AI risks, the traditional AI ML risk. The second row here includes some of the risks that are newer, introduced by Gen AI. So there's no real magic number here. This list that we have shown here is not exactly the same list that we have implemented internally. But what I would recommend is to come up with a list that's not too granular and not too broad. So there's really no magic number. I would recommend anywhere between 8 to 12. The key is to make sure that that list is so those categories are not too broad that makes it hard for you to come up with targeted risk mitigation and monitoring metrics. It also shouldn't be too narrow that makes it confusing or hard to act upon. We will be covering 2 specific examples here. One is about hallucination risk. The other one is about toxic content, or here we call it content safety risk, and how we can use this framework to come up with targeted risk mitigation techniques and monitoring metrics. Next slide. Okay, so hallucination risk is essentially the risk of a Gen AI tool generating seemingly correct responses that are actually false. So to, offset hallucination risk, there are a few risk mitigation techniques that we could explore. The first is prompt engineering. So by prompt engineering, I mean that we are giving the Gen AI tool guidance on, what would be, in what cases to not respond. So if you're not feeling confident enough, then it should not be generating a response. We could also implement a RAG architecture to generate more contextually relevant responses. And when you're implementing a RAG architecture, you could also include a validation LLM layer. So we call an LLM judge framework. So basically you have a second LLM to score on the responses from the first LLM to make sure that is correct. Third approach here is multi-technology solution. So basically what this is about is, consider that we have a traditional claim processing example. So we're using a Gen AI tool to do claim processing. We could benchmark the performance of this tool against traditional OCR technologies. So if there's a departure, then that could be a sense that there is some accuracy or potential hallucination risk. The last here is LLM fine-tuning. So this relates to the RAG architecture, but it's really about coming up with a fine-tuned validation LLM that really understand your organization's text and documents better, and using that to score on the performance of, or the results generated from the first LLM. So these are all examples of approach of techniques that you can implement to mitigate hallucination risk. This is not a this is not a complete list, but there's such as some examples. Next slide.
Next.
Yeah. So if we were to, so let's say that we have already implemented these techniques to mitigate hallucination risk. How can we come up with metrics to, I guess, monitor the residual risk that remain after all these mitigation techniques? So these are some examples of metrics that we can look at. Groundedness, retrieval, and relevance. These are all metrics that are available in Azure's Responsible AI Suite. What we could do, so these are all very similar concepts, but they all give you some indication of whether that Gen AI tool is generating or like inaccurate responses or hallucinating. What you could do is you could combine these three scores into some sort of confidence rating and use that to determine whether this response is accurate or whether it should be escalated. The last here is to seek domain expert feedback. So this is quite costly. So this is basically involving humans to score on the responses. What I would recommend here is so for use cases that are really high materiality in nature, I would recommend performing perhaps topic modeling to understand the type of topics that you're dealing with, and involve the subject matter experts for each topic areas, and see how the LLM responds to different topics. Okay, next slide. So for toxic content risk, or in this case, I think we're calling it content safety. So just a broader term for toxic content, also includes, I guess, inappropriate content in general. This is really a risk that's heightened by Gen AI. One good example is a chatbot that was launched by Microsoft. It was called Tay. It was launched in 2016. It was basically a chatbot that was trained on tweets. It was supposed to mimic the behavior of a 19-year-old teenage American girl. But what happened is, so within a day after launching that chatbot, it began generating offensive language and responses, and it was taken down. So this indeed is a material risk and can lead to reputational damages for organizations. So for that reason, it's important to come up with risk mitigation techniques for this kind of risk. Prompt engineering could also be applied to mitigate content safety risk. So basically, you are providing the Gen AI tool with more guidance on what would be an appropriate response and what would not be an appropriate response. So things like hate speech, self-harm, violence, sexual content, or offensive language should be avoided. Prompt engineering does not guarantee that a Gen AI solution would not generate toxic content responses, but it can lower the chances of that happening. The next solution here is prompt shield. So prompt shields, this is really about coming up with a way to prevent prompt injection attacks. In the case of Tay, that Microsoft chatbot that we talked about, Microsoft defense to that incident is that it was targeted by trolls that were trying to solicit offensive responses from the tool. So this is another solution that we can implement to prevent I guess malicious actors from soliciting responses that could really damage the reputation of our organization. Next is pre and post processing content filters. So content filters is potentially the most commonly used risk mitigation technique for toxic content. It can be applied both in the pre-processing and in the post-processing phases. So for pre-processing, I refer to scanning through the input that the Gen AI tool receives, or the prompt. And for post-processing is to scan through the content that is generating to make sure that it is, that it does not generate toxic responses. The last risk mitigation technique here is to come up with clear model usage guidance. So that means, communicating to our model users, what would be the correct way of using or interacting with the GenAI tool. So that involves a lot of training, a lot of education sessions to make sure that people know how to work with these new technologies. Okay, next slide. So to monitor the residual risk after all these risk mitigation techniques for toxic content, there are a few solutions available. The first is, so Azure has this, something they call a content, safety category and severity rating. So basically what it does is it would classify the content into 4 different categories, and it'll come with a severity rating. So you can come up with some sort of risk mitigation actions. So let's say if the severity rating of an incident of category, say the second one, violence category, then if it is above a certain threshold, then some actions can be taken. So that's one way to monitor content safety risk. The other is LLM Guard. This package has got what we call sentiment scores. So this is basically a way to kind of gauge the sentiment of the input data. It can be very helpful if you're deploying the GenAI tool in a customer-facing environment. Then incorporating sentiment analysis in that or sentiment monitoring could really help. Next is toxicity score. So this is really a confidence rating. It's based on a detection algorithm that scans through the content and makes sure and basically generates likelihood of how likely this content includes toxic material. Last is user feedback. So I would always recommend incorporating a channel for users to provide feedback. So if there is an incident that involves offensive language, then that should be reported right away. Okay, so I'll pass it back to Parisa. She will talk about model component dependency management.
Sorry for the coughing. It is pretty cold up here. So yeah, on the model component, as I mentioned, this is like the second part that we have to be considering while we're designing our AI governance policies and framework. So this comes to account when we are looking into the E23 requirement from OSFI. They're talking about the interdependencies of the data that is used in the model. And we take it a little bit further, and we're looking into the dependencies that we have within the model as well. So within the use cases, within the models, we have similar components that are shared. And if we know of that, if we are aware of that, and if we are using the best practices of using them, then it will allow us for a better governance around those models and those kind of applications. So the first thing that we are going to be talking about as a benefit of looking into the model component dependency is it does facilitate the incident management. So when we are aware of the components that different use cases are sharing with each other, then we are able to manage it in a more timely manner. So for instance, if we know an underlying LLM is going wrong, and we have all the use cases that are sharing the same LLM, then we know exactly where to go and how to mitigate those risks. The second benefit is expediting change management. So if we are having a decision of changing the underlying LLM or a embedding model, then if we want to change that for the whole organization, we know exactly where to look for while we're updating those material. The last thing is the enabling the bulk validation exercise. So a part of our work in the AI governance team is the validation part as well. So we're looking into the models that are developed in the global organization, and we're looking into validating them and going through the components of it and ensuring that they're all adhering to all the rules and regulations that are assigned for the financial institutes. So a bulk validation is something of concern. It just kind of reduces the amount of resources that has to be going through all those exercises that are very rigorous at some point. And if we have the models that are sharing similar components, then if we're validating one, it means that the rest of them are kind of like following the same routine. Now, a little bit of cheat sheet of like how to do that, or kind of like what are the best practices, basically, let's put it this way. So for facilitating incident management, as I said, enhancing responsiveness, so we are going to be fast responding to the incidents that are happening, and we are kind of like improving our oversight and compliance, basically, based on that information. Now, how can we kind of like come up with those ideas? We have to have the robust model inventory system. We have to have a system that can capture all of those information, all the components of the model, anything that is like embedded in anything related to like the underlying LLM embedding model, the RAG architecture, whatever that they are sharing. And in the case of traditional AI ML, maybe like a shared package or something that the applications are actually using. So in case of something going wrong, we know exactly how to kind of like put our effort on. Now, another thing that can help is like an automated alerting and diagnostic. So another thing that basically an AI governance is actually mandating for all the model developers is the monitoring system. So we have to have a system to kind of like review the model performance as well as the model validation type of thing. So there might be changes in different components of the model that are no longer adhering to all the rules and regulations that we are kind of like entitled to follow. So having all those information in that inventory and having an automated way of kind of like finding those incidents gives us an idea of how to kind of like manage those risks in a timely manner. And also having like a system that kind of like manages those incidents. So who should you go to when you're figuring out an incident? So there should be like a person or like a function that kind of deals with all of those incident management part of things. Another benefit, as I said, is the expediting change management. It kind of increased the agility and the efficiency of the change, managing the change in the use cases. First thing is the component-based model segmentation. So basically, if we are capturing all of those information in the model inventory, we know exactly which model is sharing which part of component. If we are deciding on the change, as I mentioned, if we are deciding on going with an underlying LLM model for instance, we are using like GPT-4, now we're switching to GPT-4o. Then we know exactly which models or which use cases or which applications are going to be impacted, and that's easier to kind of manage. Also, there might be some like assessment tools that we can utilize by leveraging analytics to kind of like come up with ideas of how we can do those change management more seamlessly. And integrated testing framework. So those are having like all those information about the components gives us the opportunity to kind of come up with a testing kind of framework that can be applicable to all of those applications. Now that we're changing those, we're not going to go through the validation one by one anymore, but rather it's going to be like a bulk validation that we can perform, and we can kind of do the testing for all of them at the same time. Or we can kind of like build those kind of like testing frameworks that can be applicable to a lot of different applications as well. The last thing that I mentioned is, as a benefit, was the bulk validation exercise. As I said, again, if we know use cases are kind of like sharing the components and sharing the purpose, we can kind of come up with ideas that we can kind of do the validation as a bulk. That helps with the scalability of the validation exercise that we're doing internally, and also it kind of like helps with the continuous feedback loop that we are providing to the whole model development team in the organization. Now with that, we're going to move into the proactive jurisdiction-specific compliance management, where we are kind of focusing on the models that are kind of working in the same jurisdiction, trying to come up with an idea of how we can apply the model validation, model governance around those models. I'll pass it to Sean to walk us through that.
Proactive jurisdiction model compliance management, that is a mouthful of words, but essentially what we're saying here is, is how can we automate compliance management? We know that, in the space of AI, regulations are changing every day. So with this constantly evolving regulatory landscape, how can we come up with a system to quickly react to these regulatory changes? So this slide here I have shown all the AI-specific regulations that are currently in place across the globe. I've highlighted the ones that are relevant to our organization, but this is just a list that you can refer to. This does not include model risk regulations, so E23 is not shown here. These are only AI-specific regulations. What you will notice here is that these AI regulations, they are governed by different jurisdictions, but there are also some that are, that are very specific to certain practice areas. One example is the New York 144 law here, highlighted there on, I think, top right corner. So that law is it's a New York City law that only prohibits the use of AI for hiring or recruiting purposes. There are ways to get around that. So it does, specify, what are the requirements that are needed in order to implement AI in the recruiting space. So what I would suggest here is, in your model imagery, it's important to map out not only the jurisdiction, not only the country level jurisdiction or national level jurisdiction, but also the state level jurisdiction and the practice area that is most relevant to that AI use case. What we would recommend doing here is, begin tracking those information. And the reason for that is it can lay down the foundation for what we call an automated compliance check framework. So what I would suggest is, initially to work with your legal team to understand, the different regulations that are applicable, and begin tracking those information in the model imagery. So jurisdiction level information, practice area level information, then working with their compliance team to break the compliance requirements into a checklist that can be implemented. And once that is ready, you can deploy it against the use cases that are currently in your imagery if you can implement as a checklist. And another benefit of this is because the AI regulatory landscape is ever evolving, by knowing which models are governed by which regulations and the practice areas of those models, you'll be able to react very quickly to changing regulations. So let's say if a new regulation were to come out, exactly what type of models are going to be impacted in your model imagery. So that is a key benefit of this here. So to wrap up, so the reason we call this a portfolio management approach is we got to recognize that the model risks should not be managed in silo. They should not be managed independently. There are dependencies across use cases. So we talk about risk profiling, right? So recognizing that there could be concentration risk, recognizing that model components could be interrelated, and the need to also map out the jurisdictions, because the model jurisdiction part is really messy. There are competing jurisdictions, different requirements, and making sure that you'll be able to react in this evolving space is really important. One thing that so Teresa talked about change management, and that is one key benefit that I would like to stress is, so I know that many organizations are depending on a few select LLMs, so there is that concentration risk, but what happens is traditionally, if a model were to go through a change, there would be a trigger review from an MRM perspective. So MRM would need to be involved in making sure that model update is sound. But what happens if you have 100 or 200 or 300 use cases that depend on a single LLM? Would you have enough capacity to manage that at scale? So being able to map up these information in the model imagery and come up with more automated solutions that perform these validations and reviews, I think is key for managing AI in the future. Thank you so much, everyone.
Thank you.
Thank you, Sean. Thank you, Parissa. Do we have any questions from the audience for them? All right. Well, if you happen to snag them in the hallway, and you can certainly chat with them later. Thank you so much, Sean. Parissa's actually going to stay up on stage with us here, and I'm going to call Carrie up on stage to join us, I think, for our next panel.
Okay.
I think Sean is joining us.
I think
for
I'll
the
also be
panel as
joining
well.
this.
Excellent. the surprise guest. So that's going to be really fun.
Surprise. And
grab my notes
who
real
should I
quick.
give the clicker back? I can
Sorry.
hold it.